This edition of the Bio Report is brought to you by the California Technology Council, providing discounts on products and services essential to every startup. For more information, visit californiatechnology.org/member benefits. I'm Daniel Levine, and this is the Bio Report. The power of genetic engineering will soon be available for the home thanks to the Amino One, a piece of hardware about the size of a laptop computer that would allow users to manipulate the DNA of microorganisms for productive purposes or just plain fun. We spoke to Julie Legault, founder and CEO of Amino One's creator, Amino Labs, about the device, its target market, and the implications of putting the tools of synthetic biology into the hands of kids. Julie, thanks for joining us.
Thank you for having me.
We're going to talk about Amino Labs and the Amino One, which promises to allow anyone to perform genetic engineering or synthetic biology in the comfort of their own home. Perhaps you can begin by describing the Amino One. What exactly is it?
Sure. So we've built a way for, as you said, anyone to do bioengineering. And to do that, the hardware, so it's a hardware platform, and you can think about it a little bit like a laptop computer. It allows you to run different DNA programs. And DNA programs means so you have a cell, and when you want to bioengineer, you want to put like a different program in it. You want it to do something different than it's already doing or supposed to be doing. So those are called DNA programs. So for example, you can make things glow like a firefly. You can make a yeast, like the same ones you use for baking, glow like a firefly, and that enables you to make a nightlight, for example.
So would this essentially be considered a bioreactor? Or?
Yeah, so Amino is a bioreactor. So it helps you put the DNA into your yeast cell. So it allows you to do the transformation, which is basically a heat shocking transformation. So it has hot, it has cold, it has all the little liquids you need. So there's like transformation buffers, which is a salt solution, and the DNA and all that. And then once you're done with that, the other component's a bioreactor, which allows you to keep an organism alive and feed it and make sure that the pH is regulated, the temperature. But that also allows you to play with it. So you can start by changing its ecosystem. So you can change the temperature at which it grows. You can change the pH. And a lot of those things haven't really been done in labs before. So that's why it also has application for research, because no one really measures pH and temperature over time in that way.
How does this compare to equipment I might find in a research or commercial lab?
Right. So they do have bioreactors, obviously, in research labs, but they don't give you the opportunity to do, most of them don't have real-time sensors on them. So you still need to take your data manually. So you need to take a little bit of the culture out and then go to like a spectrograph, get optical density, go to thermometer, the temperature, and so on. So Amino does all that over time, but it also allows you to input different components. So you can change the sugars that you put in it. You can change the different solutions you put in it. And those allow you to do different things. So, for example, again, with the firefly, there's a special component that allows it to glow brighter for a certain period of time. So you can kind of give it a boost. And you can test these different things. So that's different than when you have it in a lab. And also, we're including an option where you don't need to be there to actually feed it. So you could induce a certain solution. You could press a button. Well, if you're there, you press a button, give it a certain sugar. But from home, there's going to be a web page, and you could just press the button on the web page, allowing you not to have to be in the lab to do this. So those are more not necessarily advanced, but they're more like lab functions. so that grad students don't actually need to be standing by all the time,
And who's
which
the
I think will
target
be helpful.
market for the Amino One? How would you expect it to be used?
So my target market in the long run is mostly children and their parents. So the idea of having it at home as a family, so kind of like the easy bake oven. In terms of the initial people we've gotten for the Amino One and like the user base we've collected through crowdfunding, there are some families, but there's also like research labs. There's also hackers, makers, and I think these will be really helpful to understand what we can do with the Amino One. And I think in the future we'll sort of split off the branch, so there'll be one for kids, which will be more of a like instruction based. How do you bioengineer system, and then one more for hacker researchers where you can start. Where it's just a system that they can hack into and do pretty much anything they want.
And what's the price
But
point for the product?
so right now it's around $600, and that's including one of the DNA programs. And those are handmade and hand assembled, so they're a little bit more pricey. But we'll be starting to manufacture in the spring or summer next year. So hopefully the price can go way down.
So
I'm really hoping it's only a couple hundred in the future, especially for kids to have it.
People may not realize this listening to you talk, but you're an artist and designer by training, not a biologist. As I
Yes.
understand, the Amino One grew out of work you were doing at the MIT Media Lab. How did this all come about, and what were you hoping to do?
Yeah, so that's actually like a really good point. I am definitely not a scientist, and I didn't necessarily enjoy science at school. So when I got into the media lab, I was doing wearable technologies, um, so like things like watches and all that. But once I got there, sort of like the fad of wearable technology was becoming more and more mainstream, so it kind of lost its appeal. So I was researching olfaction and hormones and all that, and I got into a workshop for synthetic biology and being interested in a different aspects of the workshop. But while I was there, I learned that you could actually, most of the perfumes that they make nowadays use synthetic biology. And then by looking more into this, I found out that actually like all our medicine, most of our food, like is like has some sort of synthetic biology or bioengineering component to it. And I thought it was really important for people to start to understand it. And so I got into this workshop, and we basically transformed an organism to produce violacin, which is a anti-cancer compound used in research. But what really amazed me, well, it was kind of the color. It's like a really deep purple, which as an artist, it's kind of amazing that we could take this like beigey organism and make it like a really beautiful color. But also the fact that we did it in a kitchen, like around bagels and coffees. And it was like this really important research thing that we were doing, but it was super easy. It was super fun. And it didn't feel like science at all. And it got me to thinking that more people should be able to do this. But also, when I was speaking to my friends about this at MIT, and they're all like super smart people, a lot of them were still kind of scared, and a lot of them were saying, "Oh, you're going to become a bioterrorist." And I was like, "Well, I don't think so." But it made me realize that there's still this like innate fear of biotechnology, and like if you say I'm bioengineering something, of course it's kind of scary because that's what the media is portraying it as. And I mean, there are some scary things about it, but I think that the more we actually learn, like everyone can learn about it, the more we'll feel comfortable taking part in the debate and understanding that there are some really cool things that can come off of it. So the idea of doing a hands-on kit, which is like inspired by Arduino and all these things, is because once you do something hands-on, you feel a lot more comfortable taking part in the discussion, and you also feel a lot more comfortable learning about it. So it's less this abstract textbook subject. It's more like something, oh yeah, my kid did this in class. He brought home like a nightlight or something. Then you feel more comfortable having it in your life and understanding all sides of the issues.
Well,
Anyways,
when I was a kid,
so.
it wasn't unusual that someone might have a chemistry set or some kind of circuitry kit from Radio Shack. Is this just the equivalent of that for a new biological age?
Yeah, I think so. So, like the kit you mentioned from Radio Shack, like the 160 in one, I think that got a lot of us and maybe a bit of an older generation into electronics. And at the time, electronic engineering was like the big thing you should know. And now we know like it's everywhere. And, circuits are really important. And now everyone's hacking them. So I think, yeah, it's the equivalent. It's the well, I'm trying to make it like the bioengineering science kit for now.
So one of the things you envision selling is a set of what you call apps for the Amino One. Can you describe an app and the different types of apps that you hope will be available?
Sure. So an app is basically everything you need to produce a product, like a living product. So that includes, so there's a DNA program, and that's the part of the plasmid. So it's a little plasmid. You don't need to know these words, but that's what tells the cell what to do. So it tells it to glow, it tells it to smell like bananas, or it tells it to produce a fuel, for example. And these are things we'll provide you, but in the future, we're hoping that people can start making their own DNA program. But that's an aside. So you get a DNA program, you get the organism you put it in. So that's either a strain of friendly bacteria or a yeast cell. The same yeast that you find like in your baking kit. And the friendly bacteria is a E. coli strain, and that's the same one they use in labs. It's the friendly version of E. coli. So there's a lot of types of E. coli, and that's the nice one. So you get that, and you get transformation buffer, which is the salt solution, and that allows the membrane of the cell to become permeable, so it allows the DNA to go in it once you start putting it in the hot and cold and hot.
So what are some of the things you hope to do with the different apps?
Yeah. So, well, the first one is the nightlight, and I thought that a living nightlight would appeal to kids at home and just sort of be pretty cool because we all used to catch fireflies and whatnot. But in the future, what I'm really excited to be working on is one that allows you to do different flavors and scent. So in terms of yeast, you can change the flavor that yeast has and the different colors. So that allows you to bake cakes and brew beers that have different properties. So right now, already like out there's a rice called the golden rice, and that's been engineered to have more vitamin A, and that's like being used in Asia because they have vitamin A deficiency. So they're using this like enriched rice to help people have more vitamin. So you could do the same thing with amino. So we're working on different yeast variety you can have. I'm really excited about the perfume aspect of it and the cosmetic aspect of it. So already in our cosmetics, it's mostly engineered stuff. So I think that'll be really exciting for myself. But then we also have things that, so one of the more controversial ones, but that can help us think of what the future can bring, is that you can already start making your insulin at home. So insulin right now is made with yeast, and there are companies, there's actually only 2 or 3 companies that actually make it right now, which is kind of scary when you think about it, that there are only 3 sources of insulin for the whole world. And these are made in giant bioreactors with yeast. So you transform the cell and then it produces insulin. But if anything happens to those places, then there's like a shortage of insulin. And that would be really dire for some people. So we like to think about it as the idea of distributed medicine, where anyone could start making the insulin they need. And either you have it at home or there's one on your street, in the village, whatever. But it's this idea of having access to something you need and like sort of personalized manufacturing. So I think insulin is a really powerful one. Obviously, things like safety and injecting something you've created, if you're not trained for it, something that needs to be looked into. And like, how do we make sure people are safe? So that's like more of the future, but that's a future where we're pushing towards, where you can make your own medicine, you can make your own engineered food safely without having to rely on big manufacturing systems.
If you think about things like living night lights and banana scented yeast, it's all fairly innocuous, but when you talk about genetic engineering and synthetic biology, there are terms that certainly can set people off. Are there regulatory issues at all in selling the kit?
So in America and Canada, there aren't. So everything we do is rated biosafety level 1, and that means you don't need to have anything particular to use it. It means it's safe for humans to be around with like minimum protection. So actually we use gloves, but the gloves are more to protect our experiment from us than us from it. So in North America, there's no problem. In Europe, so in the UK and in France, it's a little bit more complicated. So you're not legally allowed to engineer anything. You can have all the parts, but once you put them together, then you're in trouble unless you're a registered school or club that has like a special registration. So, right, so it doesn't really work for France or the UK at the moment, but I know a lot of people are trying to make it work so that at least science clubs can start doing it at home, or not at home, at the club.
So you mentioned the response of some of your MIT colleagues, but I'm wondering, as it's gotten out there, the thought of putting bioreactors in the hands of home users, have you heard from other people who are nervous about people misusing the product?
So there was a few Facebook comments that were like, "Oh, here comes the zombie apocalypse," and all that, which I find a little bit funny. But at the same time, I find it funny not because I don't think I have a responsibility, but because if anyone that can create something bad with bioengineering at the moment definitely doesn't need my kit to help them. Their skills are way beyond what I can do or what my science partners can do.
Well,
and the other thing I wanted to mention is that if you want to get something like a part of a DNA produced, that's I'm going to call it evil, but that's like not good for people. That could be dangerous. There are already channels in place where if you call up a company and be like, produce me this DNA plasmid, they'll know if it's dangerous or not, and they'll check up on you.
So well, on the flip side, do you see this having the ability to demystify the technology and make it less threatening to people who may not understand it today?
Sorry, what was the question?
Well, for a lot of people, this is a nebulous area, and they're very fearful when they hear about it. But do you think by putting it into the hands of people who can learn about it in their own home, does this demystify the technology and make it less threatening?
Yeah, that's actually what I'm hoping. That's where I started from with this project, is to try and demystify it and make people less scared, but also feel like they have a bigger part in the discussion. So maybe you learn more about it and you're still very opposed to it for religious beliefs or others. And like, I'm not going to say you're wrong because these are your beliefs. So at least once you know a little bit more about it, then you can start to take part in the discussion, but also say, actually, I don't want my food to have been engineered, or I don't want my medicine to have been engineered. And then at least you know more. You know what you're saying. It's not just a bland fear that's like a blanket fear.
And you mentioned you were crowdfunding. You were on the Indiegogo site raising money for this. What's the reaction been there?
A lot of people have been really excited. One of the best reaction we got, actually, and I mean, everyone's been excited, from researchers and a lot of people saying, "Oh, I've expected this for years," or "Finally, there's a new science kit for this generation." But one of the best message I got personally is from a little girl in the UK, I think, and she's 11, and she wanted to know if she could use it and safely. And then once I answered, she said she thought she was going to ask for it for her birthday present. And I thought that was really that's the best reaction I could hope for, that an 11-year-old is interested enough to want it.
What do you think this says about biology today and the changing way people will use and interact with these tools?
I think it says that people are more open to science in the everyday life, I think. The idea of like anyone can do science in the same way that, like you said, chemistry set. Everyone, when they were a kid, could at least play with it, even if they didn't want to become a chemist. You could get an understanding it and a hands-on understanding of it. I think now in schools, I remember we didn't have a lot of hands-on activities because it wasn't safe or whatever regulations they put in there. But that also meant it was super boring. So I think this idea of playing with science and learning through doing is really important. And I think with it's something that Arduino kind of brought back, where you could just learn electronics by, plugging in a LED and being like, wow, I made this happen. I didn't have to read a book to do it. And then, of course, some people will want to read further into it, but other people will just be happy that they got to play with it.
And when does it become commercially available?
So the first ones are shipping out in March, and those were through the crowdfunding. And then we're manufacturing in the spring, so hopefully by summer you can start pre-ordering the full-on manufactured version, which will be a little cheaper than the Indiegogo ones.
Julie Legault, founder and CEO of Amino Labs, creators of the Amino One. Julie, thanks so much for your time today.
Thank you for having me.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.